Okay.
Hi, my name is Nathan Young, and the three adjectives I would use to describe myself are excitable, driven, and curious. I'm a PhD student in the Geological and Atmospheric Sciences department, and I'm also in my co-major is the Environmental Science interdisciplinary program. I look at how fluid flows through cracks in the subsurface. Specifically the fact that you see two different kinds of fluid flow in this material. So when groundwater is moving through till in the subsurface, if there are no cracks present, it looks approximately like if you have a sandbox in your backyard and the sandbox fills with water during a rainstorm and is completely saturated. The movement of water in that saturated sandbox is going to look a lot like the movement of water in unfractured till. Now when those cracks are present, you can get fluid moving through the till that's moving very, very slowly because it's hard for water to move through till. But you can also get very fast fluid movement going through those cracks. And so I'm trying to understand how large of a role those cracks are playing in enhancing fluid flow and nutrient transport in the subsurface. This is the very exciting part of the work. Actually, this is probably where most of the action happens. These cores are very slow moving. Boom. I would say that my research most closely looks like a Rubik's Cube. Anytime someone is working on a modeling project, I think that there is a solution buried in there somewhere, but you kind of have to play around with it to completely understand both the system, the code that you're using, and the different parameters that you have to use to abstract that system from what it looks like when you go and dig a hole in the ground into a mathematical construct contained on a computer. And there's a lot of playing around that goes into working with models. I would say that the models that I build work properly about 15 to 20% of the time. And when they aren't working correctly, it's largely a result of we're trying to determine specific parameters within the model and what those values are so that we can approximate what we see in the field. And the parameters that we're working with may have a range of values that sometimes may span a couple of orders of magnitude, and finding what the range of parameters we need to use, what values we actually need, a process called model calibration. That's something that's pretty laborious and can result in you getting some fairly wonky numbers in the beginning. Things that I like to do for fun, I really enjoy cooking. I also enjoy making coffee, which sounds really nerdy, but there is a lot of art and science that goes into getting the right water temperature and the right grind and the right amount. I also really enjoy hiking, particularly in areas far away from where humans have been improving things. A few seconds.
Good thing I didn't have my coffee yet, otherwise my camera would be a lot more jittery than what it is now.